Hello everyone, welcome back to our channel. We are here to solve yet another very interesting Leetcode question. It's called valid triangle number. First of all, we'll try to understand the question, then we'll look at the brute force solution, then we'll work our way to the optimal solution. Finally, we'll look at the code as well. So watch the whole video, don't miss out. And I assure you that if you watch this particular question and the pattern underlying this would be crystal clear to you by the end. So without wasting any more time, let's get started. Given an integer array nums, return the number of triplets chosen from the array that can make triangles if we take them as side lengths of a triangle. Okay. So let's try to understand the question first. What is a valid triangle? Okay. That's the question. That's the first thing we need to understand before we even start solving this question. Like, when do we have a valid triangle? This is X, this is Y, and this is Z. So the condition for a valid triangle is very simple. It's that x plus y should be greater than z, y plus z should be greater than x, and z plus x should be greater than y. In simpler terms, sum of any two sides of the triangle should be greater than the third side. That's it. That is how you check validity of a triangle. Now let's move on to the question. So given a set of numbers, we have to tell how many triangles can we make out of those set of numbers, with those set of numbers as the sides of the triangles. Okay. So let's have a look at an example to get a little bit more detail on this. Okay. So let's take a random example. 2, 2, 3, 5, 6, 8, 9. Okay. Let's try to work our way through with this particular example. Now we have to pick three numbers. After picking them, we have to find out whether it is a valid triangle or not. The O of n cube solution is very natural. It's very easy for you to solve it this way. This is the brute force solution. What do we have to take? We have to take every possible triplet, find out whether it is able to form a triangle or not. If it is able to do that, you increment a counter. That's it. At the end, you return the counter and you get over with it. That's the simplest way of solving this, but this is the brute force solution, takes O of n cube time. We need to improve upon that. Before we do that, let us try to write the pseudo code for this particular solution. And even before that, let's try to see some of the triangles that we can form using these numbers that we have. So can we form a triangle using these three as sides? 2, 2, and 4. Take any pair. 2 plus 2 is 4, that is greater than 3. 3 plus 2 is 5, that is greater than 2. So take any pair of sides. Its sum is greater than the third side always. So yes, that is a valid triangle. Okay. And similarly, let's take another one. 2, 5, and 6. Again, take any pair. 5 plus 6 is greater than 2. 2 plus 5 is greater than 6. And 6 plus 2 is greater than 5. So this is another valid triplet that is forming a triangle. So like this, we just have to find out how many such triplets exist in this particular array. So now I'll write the pseudo code for the brute force solution. Okay. So you take every possible triplet. Before that, you initialize a variable answer. This is basically our counter. And now we take every possible triplet. That's very easy to do. So you loop from 0 to n minus 1 with an iterator I. Inside this loop, you again loop from I plus 1 to n minus 1 using an iterator j. Inside this loop, you again loop from j plus 1 to n minus 1 using an iterator k. Once you are inside, you just have to check this condition that I gave you earlier. Sum of any two sides should be greater than the third side. That's it. So let's see. If array of I plus array of j is greater than array of k, and you just have to write all the three conditions here. Array of j plus array of k is greater than array of I, and array of k plus array of I is greater than array of j. If this condition is met, if it is true, that means that we can form a triangle out of this particular triplet. So what do we do? Inside this if condition, we simply do a answer plus plus, and that's it. That is it. By the time we get out of all of these loops, we have our answer that we can simply return and be done with it. Okay, this is the brute force solution. There is a loop inside a loop inside a loop. That is why their time complexities get multiplied n into n into n O of n cube time. So I hope the brute force solution is clear to all of you. If there's any doubt, please feel free to put it in the comments. I'll be more than happy to take the doubts. Moving forward to a more optimal solution, let's see how we can optimize it, okay? Again, taking the same example, 2, 2, 3, 5, 6, 8, 9. So now we will apply the two-pointed technique on this. We have a S1 and we have a S3, okay? S1 is at the starting, S3 is at the end. And then we have a S2. That is, let's say it starts from here. Now, before we apply this technique, we have to sort the array. I'll tell you why we have to sort it. But just understand that we have to sort it. This array is fortunately already sorted, but we have to sort the array. It's not given that the array is already sorted, okay? Now, keeping this fixed, okay? S3 is fixed. Just assume for now, okay? Bear with me for a minute. I'll explain to you everything in detail. S3 is fixed over there. And we can move S1 and S2. And we have to find out with this as our longest side, because this is the rightmost number that we have chosen out of S1, S2, and S3. With this as the longest side, how many triangles can we form? Now, look at this very carefully. Can we form a triangle right now? 2, 8, and 9. Yes. Why? 2 plus 8 is greater than 9, right? So that automatically means 9 plus 2 is greater than 8. And 8 plus 9 is greater than 2. Because 9 is the greatest side. So if S1 plus S2 is greater than S3, then S1 plus S3 and S2 plus S3 are also greater than the remainder side. So yes, we can create a triangle out of these three sides. I'll just write it down over here. But listen to this very carefully. Can the value of S1 be anywhere inside this range and still the condition will be true? What I'm saying is, if S1 plus S2 is greater than S3, we can move S1 from its current position up to S2, and this condition will always be true. This is what I'm proposing to you. Because when we move S1 to the right, let's do that. When we move it to the right, the numbers will only increase, the sum will only increase. So if S1 plus S2 is greater than S3, this condition remains true throughout. So we don't actually move it from there to there. What we do is we at once, like 0, 1, 2, 3, 4, 5, 6. What we do is to our answer, to our counter, we straight away add 5 minus 0, that is 5, because there are 5 triangles possible with this S3 and this S2 by changing the values of S1. Let me show you. The other triangle is 8, 2, 8, 9, then 3, 8, 9, 5, 8, 9, and 6, 8, 9. All of these are valid triangles, but we did not have to move or iterate over every single one. From the current values, we have derived it. Why? Because we have the array sorted. So this is where the sorting comes in handy. Why can we say that with all these numbers, this condition will remain true? Because we know that all the numbers on the right of S1 are greater than S1. Okay? I hope this part is clear. If this part is clear, the question is very easy from now. From here on onward, the question is very easy, guys. Okay. Now what do? We move S2 back. Okay. With this S3 and S2, these are all the possible triangles that we could create. There are 5 in number. We move it back. Okay. Now, is this possible? 2, 6, and 9. 2 plus 6 is equal to 8. 8 is less than 9. So this is not a possible situation. In this condition, what do? We have to move S1 forward. Okay, we move S1 forward because moving S1 to the right will increase the sum, and that is what we want. We want S1 plus S2 should be greater than S3. So we move it to the right. 2 plus 6, again 8, not a possible triplet. Move it right. 6 plus 3 is 9. It should be greater than the third side. As I said, be very careful about it. Equal doesn't work. Greater than the third side, so still doesn't work. We move it to the right. 5 plus 6 is 11, greater than 9. It works. How many such triangles are there? How many such triangles are there? S2 minus S1, 4 minus 3. One such triangle is there. 5, 6, and 9. And that is it. With S3 fixed, these are all the possible triangles that we could create. These 6 triangles. That's it. Then what do? We move S3 back. Now, there is one very interesting thing that you need to look at. For a particular S3, this whole code ran in O of n. For a fixed S3, the whole code ran in O of n. Because once S1 and S2 meet, we are ending this particular iteration. So we have to do it for every single value of S3. So O of n into n, that brings down the complexity to O of n square. Okay, this is how we brought down the complexity from O of n cube to O of n square. We also added sorting. So it is basically O of n square plus n log n. And as you already know, n log n is less than n square. So this is basically equal to just O of n square. All right, I hope this much is clear to you. If this is clear to you, next we are going to move towards a pseudocode for this. Okay. So look at this very carefully, guys. And once again, I'm telling you, whatever doubts you get, you keep putting them down in the comments. And I'd love to clarify all your doubts for you. So now coming to the optimized pseudocode. Okay, look at this very carefully. Very easy, let me tell you. This is very easy. Once we have understood the whole logic, creating a pseudocode and then converting the pseudocode to the proper code is very easy. All right. So let's have a look. Look at this very carefully. First of all, what are we going to do? We're going to take the counter. Answer equal to 0. We're going to initialize it to 0, of course. After this, what are we going to do? We're going to enter a for loop. Now inside this for loop, we're going to create our side number 3. We are going to start it from the end of the array, right? From the last number, as we were doing over here, from the last number. And S3 greater than 1. Why are we not putting S3 at 0 or 1? Because we want a triplet, right? So S1 can be at 0, S1 can be at 1, then S3 can be at 2 minimum. It cannot go behind that. And then S3 minus minus. Inside this for loop, we have another for loop. In this for loop, we are taking the other two sides, S2 and S1. So S1 is going to start from 0, while S2 is going to start from S3 minus 1. Okay, this is what we have done in the method as well. We were starting S2 from S3 minus 1, right? We are going to run this loop till S2 is greater than S1. The moment they collide or the moment S2 passes, we are going to stop the code. There is no third condition. We adjust values of S1 and S2 inside the for loop. Now coming inside the for loop, what exactly do we have to do? Look, this is the easy part. Look at this very carefully. Okay. First of all, we have to check if this current triplet is working or not. That's it. So if array of S3 is less than array of S2 plus array of S1, what do we have to do in this case? It's very simple. In answer, we are going to add S2 minus S1, all the possible triangles that are there, right? And we are going to move S2 back. Else, if this is not the case, if it doesn't work, what were we doing? We have to basically make S1, A of S1 plus A of S2 greater than A of S3. If it is not happening, we can increase this value. How? By moving S1 to the right, because it is in ascending order. So we make S1 plus plus. We make the starting pointer move forward. And That's pretty much it. When we come out of all of these loops, we have our answer stored in the answer variable. So we can simply return answer and we are done. I hope this is crystal clear to all of you. And again, if there's any doubt in any of these parts, please put that in the comment. And if it is crystal clear, type a CC in the comment so that I know that you guys are able to understand this. Now we are going to move towards the code. Okay. Okay, everyone. So now let's get to the code part. We're going to code this in C++. Let's have a look at how we are going to do this. First of all, we're going to sort the nums array that is given to us. After this, we are going to run the two for loops that we did in the pseudocode. First for S3, it is going to start from the end. So nums.size minus 1 and S3 is greater than 1, S3 minus minus. Now we're going to run the second for loop inside it for S1 and S2. So S1 is going to start from 0, while S2 is going to start from S3 minus 1. We are going to run this in a loop till the time S2 is greater than S1. And there is no third condition. We are going to change the values of S1 and S3, S1 and S2 inside this second for loop. Now, first of all, we'll check if this is a valid triplet or not. If nums of S1 plus nums of S2 is greater than nums of S3, that means this is a valid triplet. In this case, what do we do? Answer plus equal to, oh, we forgot to make this variable answer. That is going to work as our counter. So in this case, answer plus equal to S2 minus S1, and we're going to move S2 back. Otherwise, because we want to make nums of S1 plus nums of S2 greater than nums of S3, we can move S1 forward. So that is exactly what we are going to do. Because the array is sorted, if we move S1 to the right, the sum is going to increase. Okay. And that is pretty much it. When we come out of this loop, we can simply return answer and be done with this question. Let me just run this. And let me submit this now. So as you can see over here, we are able to solve all the test cases. So that is it, guys. And I hope you guys enjoyed this video and you were able to understand this question thoroughly. And I really hope that you guys are able to solve it yourself now. Whatever doubts you get, once again, put them in the comments. I'll be more than happy to solve them. I'll see you in the next video. Have a great day. Bye-bye.